Dear students, this is 10th class new maths textbook, the chapter number 1, real numbers. Here is the exercise 1.2 and this is part 1 video. In this video, we will learn the questions of question number 1 and question number 2 of exercise 1.2. Dear students, this is the chapter real numbers and exercise 1.2. Now let us look at question number 1. Prove that root 5 is an irrational number. I shall repeat. Prove that root 5 is an irrational number. Do you know what is a rational number and what is an irrational number? Good. What is rational number? As a number in the form of a by b or p by q, where p, q are integers and q not equal to 0 is called a rational number. And a real number which is not rational is called irrational number. If you still want to learn about rational and irrationals, you may please check the video of introduction to numbers. Now let us look at the solution. This question may be solved using indirect proof of solving a problem. Indirect proof. Do you know what is a direct proof and indirect proof? Yes. We generally use direct proof in almost all the problems. We use the direct proof to solve the problems. For example, you have given the base and altitude of a triangle and if you are asked to find the area of the triangle, then you may use the formula area of the triangle is equal to of BH, and we will take the values that are given in the question and finally we will find what is asked there. That is direct method. Now in indirect method, what we use is we will assume that the given question is wrong. Here what is the question? We have to show that root 5 is irrational. This is the question. We will assume that this is wrong. You see, in indirect proof, let us assume that root 5 is not an irrational number. If root 5 is not an irrational number, implies then it should be a rational number. Then root 5 is a rational number. From the definition of the rational numbers, you can write root 5 as a by b. Here you see root 5 is equal to a by b, where a and b are integers and b not equal to 0. And of course a and b in its simplest form means both should be co-primes, means both numerator and denominator should not have any common factor except 1. You have to write any number in the form of a by b where a and b are integers and b not equal to 0 and a comma b are co-primes, then you can say that a by b is a rational number. But as it is given root 5 is a rational number, we took root 5 is equal to a by b. Implies here b divides a, on the other side if we take it to LHS, then b should multiply this root 5. Therefore root 5 into b is equal to a. Since you can find root 5, in order to remove this, let us square this equation on both sides. The equation is root 5 into b is equal to a, and let us square this. Means LHS whole square is equal to RHS whole square. Means if you square this, root 5 whole square is 5 and b whole square is b square, means 5b square is equal to RHS is a whole square is a square. Okay. Now 5b square is equal to a square, means you can write a square value as 5 into something, means a square is a multiple of 5. Since a square value is a multiple of 5, this a square can be divisible by 5, isn't it? What are the multiples of 5? 5, 10, 15, 20 and so on. All these are multiples of 5 and all these are divisible by 5 also. Therefore a square is divisible by 5, or in other words 5 can divide a square. If 5 can divide a square, then you can say that 5 can also divide a. Okay, 5 can also divide a. It is the first conclusion. We arrived at 5 can divide a. This is the first value. Now since 5 can divide a, let us write a value as 5c. You see this. This is the continuation. Let us assume that a is equal to 5c and let us substitute a is equal to 5c in the previous equation. 5b square is equal to a square. Let us substitute a is equal to 5c now. 5b square is equal to a means 5c whole square. 5c whole square means here this is 5b square is equal to 5 square is 25c square. This 5 in 25 5 times. Therefore b square is equal to 5c square. Now you can observe that b square is 5 into something. Therefore 5 can divide b square. If 5 can divide b square, then 5 can also divide b. You see, 5 can divide b square implies 5 can also divide b. In the first we proved that 5 can divide a, and in the second conclusion we proved that 5 can also divide b. You see this, in first we proved that 5 can divide a. Now in second we proved that 5 can also divide b. Means 5 is a common factor for both a and b. 5 can divide both a and b. But from the definition of a rational number, both a and b should not have a common factor. Therefore, this contradicts the definition of the rational number. Since it is a contradiction to the given question, our assumption is false. Since our assumption is false, then root 5 is an irrational number. You see, our assumption is false. What is our assumption? Yes, this is our assumption. What is this? Root 5 is not an irrational number. This is false. Therefore, root 5 is an irrational number. Is it clear? This is one of the most important models or most important problem from the chapter. You may certainly get it for an essay question. Please practice this once or twice. Now look at question number 2. You see this. Prove that 3 plus 2 root 5 is an irrational number. I shall repeat. Prove that 3 plus 2 root 5 is an irrational number. In indirect proof, let us assume that 3 plus 2 root 5 is not an irrational number. Since it is not an irrational number, implies it should be a rational number. That is, 3 plus 2 root 5 is a rational number. Since it is a rational number, we can write it in the form of a by b. 3 plus 2 root 5 is equal to a by b, where a and b are integers, b not equal to 0, and a, b are co-primes. Here, at LHS, we have 3 a rational number, plus 2 a rational number, rational coefficient for root 5. Root 5 is an irrational number. Let us transfer this 3 and 2 to the other side of the equality. First of all, take this 2 to other side. Then 2 root 5 is equal to a by b plus 3 other side minus 3. Now take this 2 also to other side. Here 2 multiplies root 5. If we take it to other side, it should divide. Therefore, root 5 is equal to a by 2b minus 3 by 2. Here root 5 is an irrational number. We proved it already in first question. Whereas a by 2b is a rational number, 3 by 2 is a rational number. If we subtract one rational number from the second, again you will get a rational number. At LHS you will get an irrational number. At RHS we have a rational number. But we have an equality sign between the two. An irrational number cannot be equal to a rational number, isn't it? Therefore, our assumption is false. An irrational number cannot be equal to a rational number. So, our assumption is false. What is our assumption? Our assumption is 3 plus 2 root 5 is not an irrational number, is false. Therefore, 3 plus 2 root 5 is a rational number. By this method of indirect proof, we will solve this type of problems. This method is one of the most important methods from the textbook. You may please practice these problems once or twice. Dear students, thank you. Thank you very much.